Hello, we're going to look at some trigonometry questions, only 6, and these are all identities using sine, cos, tan. So we're going to be using sine x, we're going to be using cos x, we're going to be using tan x, we're going to be using the fact that sine x over cos x is equal to tan x, so we might use that one. We're going to use maybe cos x over sine x is equal to cot x. We might be using the fact that 1 over cos x equals sec x, and 1 over sine x is equal to cosec x, and I'll just put CSC. And also we may be using the fact that sine squared x plus cos squared x is equal to 1. All right, so we may use that as well. So we've got lines everywhere, never mind, that's just the pen playing up. So let's start with the left-hand side. The left-hand side equals cot x over some strange trouble with the marker. Sorry about this. This line here. I've got to get rid of that line. I didn't want that line there. All right. Now, over cos x, so I'll just make that a bit thinner. So we've got cot x over cos. So cot x over cos x, that's the left-hand side. Now cot x, let's use, and I'll just put here, let's use the cot x equals this one here, all right, equals cos x over sine x. So let's replace cot x with cos x over sine x, divide that by cos x. I can take that fraction cos x, the numerator, sine x, multiplied by, and the denominator is 1 over cos x. So I've just separated those out, and I can cancel that, and we're left with 1 over sine x, and that equals the right-hand side. Okay. QED. All right. Let's change the color. Let's go to the next question. Cos squared x over cosec squared x. Well, let's change cosec squared x into 1 over sine squared x. So we've got left-hand side equals cos squared x over cosec. I'll just repeat it. Now I'm going to replace cosec squared x with 1 over sine squared x. So I'm going to take that cos squared x, multiply it by, divide by a fraction times by the reciprocal, sine squared x over 1. Now I've got sine squared x, but now I'm going to replace cos squared x with sec squared. I'm going to say that cos squared x equals 1 over sec squared x, and that equals sine squared x, and we're finished. So we've got sine squared x on top, sec squared x underneath, and that equals the right-hand side. Okay, and that's how we move from the left-hand side into the right-hand side. We always start with left-hand side equals, and we finish with equals right-hand side. QED is Latin for quod etrum demonstratum, as asked to verify or as asked to show. Let's look at the next 2 questions. Well, we've got left-hand side, so we don't worry too much. Just repeat. You just write down the left-hand side equals. So we're just preparing our work. So we start with left-hand side equals. And now we start moving, we start replacing. So I'm going to have, there's no fractions in the right-hand side. So I'm going to change everything to change sec into 1 over cos squared x. That's what sec squared x equals. I'm going to leave that as sine x. I'll just put that as sine x. And here we've got 1 over, again, cos squared x. Now I could take this and the numerator divided by a fraction. I can now multiply that, if I like, by the reciprocal of our fraction. And now if we expand, cos squared x times 1 over cos squared x is 1. So cos squared x times cos squared x, that's equal to 1. And this would be sine x cos squared x. And 1 plus sine x cos squared x. And that's what we wanted. I'll just put equals, I'll just change the order, cos squared x sine x plus 1 equals right-hand side. And that's quadratum demonstratum as asked to show. All right, do I have enough space to do this one here? I'll just do it over here. Let's change the color. On my screen. All right, I'll just say left-hand side equals sec x minus tan x over sec x. Now I've got one denominator. I could, if I wanted to, what I didn't do in the first one, it would have been easier actually. I could have just written like up here. I could have gone a different way. I could have put sec x over sec x and sine x. I could have done it that way if I wanted to. And then that would have equaled to 1 plus, and you would have got sec x is cos squared x, and that would have been a lot faster. So let's split this up into sec x over the denominator of sec x into 2 fractions here. The denominator of each one will be sec x. And let's get rid of sines. Let's turn them all into sines and cos. Well, this is a 1. We don't have to do anything with that. Tan x is sine x over cos x. And sec x is 1 over cos x, which is 1 minus, I'm just going to take the top fraction and multiply it by, if it's divide 1 over cos x, it's times by cos x over 1. And then that will cancel. So we're left with 1 minus sine x. And that's what our right-hand side equals. Quadratum demonstratum. Right, how to move from the left-hand side to the right-hand side. So let's write the left-hand side equals negative cos squared x cosec squared x. All right. Now we want a minus in here, so let's just turn everything into cos and sine. So we've already got a cos squared x here. Cosec x is 1 over sine squared x. So that is negative cot squared x. Now I want a 1 minus. Now if I take the mother Pythagoras rule, if I use this, if I divide everything by sine squared x, because that will give me a cot squared, sine squared x, sine squared x. So that will equal 1. What I've got is 1 plus cot squared x equals cosec squared x, or cosec squared x. And I don't want that line. Will that disappear? Sometimes it doesn't. No, just have to rub it out. Don't want that line. That line just jumped in. All right, bear with me. Just having trouble with the screen now. All right, ignore the line. I'm going to leave the cot squared x here and take the 1 across. So cosec squared x minus 1. But if I have a negative, that means I change the order to be 1 minus cosec squared x. So therefore, equals 1 minus let's get rid of that line. Equals 1 minus cosec squared x. And that's what we wanted. 1 minus cosec squared x. Except they've written cosec squared x like that. Equals right-hand side. Notice we replaced this line with this line, but we have to put this over on the right-hand side. So we import our information from the use section. So this is using the mother rule. We've shown how we get negative cot squared x equals, and then we replace negative cot squared x. So this, you need both you need both sections. You need the use section and you need your solution section. All right, let's go to the next one. Our last question. Left-hand side equals tan squared x, sec squared x plus cosec squared x. I'm going to replace everything with sine over cos. So that's sine squared x over cos squared x. Sec squared x is 1 over cos squared x. Cosec squared x is 1 over sine squared x. On the denominator, I can make that one fraction. So I'll leave the numerator sine squared x over cos squared x. And then the denominator will become sine squared x plus cos squared x over sine squared x cos squared x. All right, so that's just adding, that's like saying that a over b plus c over d equals AD plus BC over BD. So really what I've done is I've made it one fraction, not two. Now you can see that this part here equals 1. Sine squared x plus cos squared x equals 1. So I will put the numerator, the top fraction, instead of divide by the fraction, I can now take that top fraction and multiply by the reciprocal. The reciprocal of sine squared x cos squared x over 1, because sine squared x plus cos squared x equals 1. We can cancel those, so we're left with sine 4x, and we're finished. Equals the right-hand side. Wow. Interesting questions. I hope that this has helped.